is going to be about applying our solving techniques to quadratics. So we're going to do a few different types of word problems here that are very. I've kind of tried to make sure that I'm doing problems that are almost are very similar to the ones that you're going to do on the quiz, and are very similar to the ones that you would have to do on the final exam or on labs or anything like that. So with the application of quadratics, I'm not trying to just go all out crazy hard problems out of this, but I'm trying to give you examples that are similar to what you're expected to know how to work those types of problems. So we've got 4 or 5 different kinds of problems here. And I'm going to show you how to set each one of those up. And then we're going to use those methods that we just talked about solving quadratics in order to get the answers for those out of that. So we'll do some problems that are kind of geometry related, so shapes out of that. And I'm going to show you how to do those kind of problems. And then we'll do a problem where it's more like number type relationships that we're going to talk about. So we'll start with the geometry type problems. We're talking about shapes. And the first one we're going to talk about a box that has a volume of 1,435 cubic centimeters. It has a length that is twice the width and a height of 5 centimeters. So they tell us one of the dimensions. They tell us something about the second dimension, and we're asked to find out how wide is this box. So a lot of times it's easier for me to kind of visualize what's happening by drawing a picture. So I'm just going to draw myself a little box here. It helps me visualize what's happening. So there's a box. That box has a width that we don't know. So I'm going to put a W right there. It has a length that is twice as much as the width. So the length, down this edge right here is twice as long as this one, the width is. So that's going to be 2W. Then it tells me in the problem that the height is 5 centimeters. So we know that this piece right here is 5 centimeters automatically. Now, what would be considered common knowledge for this problem would be that the volume of the box, to find the volume of a box, it's length times width times height. That's considered common knowledge for that. Make sure, if you see something about volume of a box, you know that you're going to use this formula to fill in the things that you know out of that. All right. So with that, we're going to fill in the things that we know. We know that the volume is 1,435. I'm going to put that in that place. We know that the length is twice as long as the width. So that's where this 2W comes in, 2 times the width. So that'll be 2W. We don't know the width, so that's W. But we do know that the height is 5 centimeters. Now I have a problem that has filled in all the information they gave me. So I'm taking this formula, volume, and put it in the volume. The length was twice the width, so that's 2W. The width we don't know. The height we did know. So I plugged in everything that I knew from this problem, and then I'm gonna simplify it as much as I can. So I've got 1435, and then I've got 2 times 5 would be 10W squared. 10W squared. All right. Now this problem, because you don't have a plain W in it anymore, you've got just numbers and W squared. I would think solving this by square roots would be the easiest method because you've got W squared there that you can get by itself. So I would take this problem and divide by 10. And most of the time in word problems, it's okay to convert to decimals most of the time. So that's what we're going to do here. 1,435 divided by 10. 143.5. Could have done that without that. But, okay. The next step would be get rid of the squared. So, if it helps you to rewrite it this way, some people like it better with the variable on the left. It doesn't matter though. Then we take the square root of each side. There's W, square root of 143.5. I'm going to use the calculator to help me find that. Okay. And I'm going to get an approximation for the width. So I'm going to get an about. So I'm probably going to have to round this is what's going to happen. All right. So in the calculator, second x squared, 143.5. Hit enter. It's about 11.979. So I'm going to round that to 2 decimal places. So I'm going to go 11.98. Centimeters, because that's what the problem had, centimeters in the dimension that they gave me. So the width is 10.9 or 11.98 centimeters, and then we could go from there. If they ask us for the length, we could just say that times 2 and get the length out of that. So just setting up the problem, plugging in what you know. That's the idea with these word problems, is take what they give you, figure out what you're dealing with. Okay, we were dealing with a box, so we knew volume and used that formula there. So let's look at the next problem. Another geometry type problems, because we got a shape. Okay, it says a poster has an area of 216 square inches. The width is 6 less than the length. Find the width. We're going to find the width again for this problem. Okay. So a poster, I don't know how many kids hang posters on their walls anymore. I used to do that when I was a kid. My wife won't let me now in our house. So, but posters, rectangles, right? That's what shape they are. So when we talk about a poster, it's a rectangle. And we know that the area of this thing is 216 square inches. And we find area of a rectangle by saying length times width, right? So that's the common knowledge part of this, that knowing how to find the area of a rectangle is important formula to have there. I'm trying to think. In the back of the textbook, there's a page with area formulas and things on it. Some of the formulas that you might need if you don't know them, or just hit up Google and type in area of a rectangle, something like that. I don't care which way you do that there, but the very back cover of the textbook has some of these formulas. It says that the length is, or the width is 6 less than the length. So we don't know the length. We know the width is 6 less than that. So that would be the length minus 6. Okay. So when I plug in the stuff that I know that the area is 216. So that's what I plugged in there. Okay. I don't know the length, but I know that the width is 6 less than that. So this is length minus 6. Length minus 6. Okay. So I plugged in the stuff that I know. Okay. So it asked me to find the width. I don't have a W in my equation, but I can get one later. Okay. I'm just going to find out what the length is, and then the width, we just subtract 6 from the length, and we get it. Okay. 6 less than L minus 6. If it says 6 more than, that'd be L plus 4. And that idea. Okay. So now this one, we're going to multiply everything on the right side together. That's distributive property. L times L, the L squared. L times negative 6 would be negative 6L. And then we have 216. Well, this problem is different than the first one because I have a plain L there. So I've got L squared and a plain L and then a number over here. That tells me I've got to get it equal to what in order to solve this? 0. So I'm going to subtract 216 to get this thing equal to 0. And we learned how to solve this type of problem just a few minutes ago. So I'm not expecting you to be experts at it yet, but we know that there are two options. There's factoring or quadratic formula. The only problem is that factoring doesn't always work. And we would have to do the X method for 216 and -6. That's big numbers, pretty good ways apart. That's tough to do. But we do know that quadratic formula always works out of this. So I'm going to do a quadratic formula for this problem because I know I'm going to get an answer from it. So A is going to be 1, B is -6, and C is -216. Okay? And I'm going to take those and plug them into my quadratic formula. -b plus or minus the square root of b squared minus 4 times a times c over 2a. So I'm just remembering what quadratic formula is. And then I'm plugging in the stuff that I know. I know that -6 would be +6 plus or minus -6 squared minus 4 times 1 times -216. And then over 2 times a, 2 times 1. So I'm going to use a calculator to help me do the discriminant here and get that number. So parentheses, -6, close the parentheses, squared, minus 4, parentheses, 1, parentheses, -216. So I'm just typing in the discriminant. It's 900. Ooh, that's a big number. But here's the beauty in it. I think it's got a nice square root. Okay. I'm going to type it in because it's a word problem. I know the decimals are okay. So I'm just going to type in the square root of 900 on my calculator. Hopefully it is a nice number. I'm pretty sure it is. It's 30. If it were, 26.45, you'd round it, use that decimal because it's a word problem that we're dealing with here. So you can use decimals for word problems. So 6 plus or minus 30 over 2. Those are the, and then we just work those out. So the length is 6 plus 30 over 2 or 6 minus 30 over 2. Well, 6 plus 30 is 36 divided by 2. 36 divided by 2 is 18. So that tells me the length is 18. If I work out the other side, I'm doing 6 minus 30. Get -24. -24 divided by 2 is a negative number. Can a length ever be negative? Can you ever measure a board or a poster and it have a negative number on it? No. So I know that this is not even an answer. Okay. So 18 has got to be the length. What does the width have to be? Yeah, 18 minus 6, which is 12 inches. Happens to be the same number as this one, but it's positive for that. Okay. So anytime you get a negative answer on a problem where you're measuring something, you know that negative answer is really not negative. Okay. Because lengths or measurements are never going to be negative as far as measuring length of something or size of something. Never going to be negative. Okay. So there we have an area problem. So we've done a volume problem. We've done an area problem. Let's do one with a triangle and see what we can do with that. So you remember probably most everybody did this, in about every grade starting in at least 6th grade. You did this a squared plus b squared equals c squared. Anybody remember what that's called? Yeah, something there. It's named after this guy named Pythagoras. So it's Pythagorean Theorem. And it only works for right triangles, okay? So right triangles are triangles that have a right angle in the corner, but this is 90 degrees. That's what the box there in the corner means, is that it's 90 degrees. And A and B are the sides, and C is what's called the hypotenuse. C is always the slanted side. That's the way it always is. Okay, but it doesn't matter which one you call A and B. A can be the short side, the long side. It doesn't matter. But C is the one that's always slanted or across from the 90-degree angle. All right. Now, when we're dealing with Pythagorean theorem problems, I'm going to be dealing with right triangles. Okay, so let's get us a word problem that deals with that. Okay, so a piece of property is a right triangle shaped lot in the subdivision. So a lot of times there'll be a lot there in the corner that's a triangle shape, and trying to survey it off there. They guys that do surveying now have some nice tools that do things with lasers and GPS coordinates, and it does all the area and stuff for them. But to get certified, you got to pass the test without that stuff, and you got to do all this triangle math out of that. So being able to do this is where that comes from. But let's say we know something about that measurement, about this lot, and for whatever reason we know it in the way that I'm going to describe it here. And that the longer leg is 20 yards longer than the shorter leg. The longest side and in parentheses I'll write hypotenuse is 10 yards longer than the longer side. Longer leg. Let's use leg. That's what I used earlier. Find the lengths of each side. All right, so we've got this right triangle shaped piece of property. Right triangle here. It tells us, it says that the longer leg is 20 yards longer than the short leg. So here's the short leg. We don't know how much he is. Okay, but it's short leg. The longer leg, which would be this one here on the bottom, is 20 yards longer than that. So I'm going to say that's x plus 20. And then this line right here, this is the tricky one. It says the longest side, the hypotenuse, so that's the one we don't know anything about yet, is 10 yards longer than the longer leg. So if it's 10 yards longer than this one, what could we write in its place? X plus 30 is right. Yeah, good job. Good job. So x plus 20, and x plus 30. If we can find out what x is, then we can find the rest of them pretty easily. Okay. Now, finding what x is a little difficult here because it is a right triangle. And to be a right triangle, that means that the Pythagorean theorem works for you. So a squared plus b squared equals c squared. A, I'm going to call it x. B is got to be this x plus 20. And C has got to be the hypotenuse, the x plus 30. Now, that doesn't look too daunting at the moment, but in order to work that, we need to get this to look like a quadratic like we did in the first section of the day, okay? So in order to do that, we've got to multiply out these two pieces and then work this to get it equal to 0. Because I think I'm going to have some plain x's and I'm going to have some x squareds to put together here. So when I multiply that out, that's x plus 20 times x plus 20. And on this side, it's x plus 30 times x plus 30. So distributing both of those out here. So x times x is x squared plus 20x plus 20x plus 20 times 20 would be 400. And then I've got the x squared that I started with there in the front too. And on the other side, I'm distributing x times x is x squared plus 30x plus 30x. And 30 times 30 would be 900. So I'm multiplying that out, which honestly is the harder part, I think, to this problem. Once we get it simplified, it's not going to be so bad. So I'm going to put some stuff together here. I got x and x squared. X squared and x squared is 2x squared. 20x and 20x would be 40x plus 400 equals x squared. 30x and 30x is 60x plus 900. Now I'm just going to get it equal to what? And so that I can solve it. 0. Okay. So I'm going to subtract x squared. It's going to give me x squared. 2x squared minus 1x squared is x squared. I'm going to subtract 60x. So that'd be negative 20x. And I'm going to subtract 900. 400 minus 900 would be negative 500. That cancels out everything on the right side and gives me a quadratic that's in the form where I can do quadratic formula for from there. Okay. So this Pythagorean theorem problem's a little tougher. But again, once we get to this step, it's just quadratic formula. But the hard part's all this stuff we did up here, because there's a lot of operations there, a lot of places you can make a mistake. One mistake would be enough to give you a different number and make the whole problem wrong. Okay, so be very careful about those. Okay, now last step would be set up a quadratic formula for this. So I know, give myself enough room here. I know that A is 1, B is negative 20, and C is negative 500. That's my A, B, and C. And I'm going to put that in the quadratic formula. Negative B, 20 plus or minus B squared, so negative 20 squared minus 4 times 1 times negative 500. So probably going to be a big number underneath that square root over 2 times 1. Okay. I'm going to simplify that. So it's 20 plus or minus. I'm going to use a calculator to help me get what's underneath that square root. So parentheses, negative 20 squared minus 4, parentheses 1, parentheses negative 500. 2,400 under there. I don't know for sure that 2,400 has a square root. That's nice, but I'm going to try it. It's not real nice, but I can use the decimal here because we're dealing with a real world problem. So I'm going to round that to 2 decimal places. So it'd be 48. So that's 20 plus or minus 48.99. Because this third 9 makes the 8 go up to a 9. And that third place makes the 8 go up. Okay. And then that all is divided by 2. So I know that I'm going to take 20 plus 48.99 and divide that by 2. And that'll get me the short side. If I do the minus, I know I'm going to get a negative answer. So I'm not even going to worry about doing that. So I'm not going to do the 20 minus 48.99 divided by 2. That's going to give me a negative number. So I'm just going to throw that one out because I know I can't have a negative measurement anyway. Okay. So work this out. 48.99 plus 20. And then divide that by 2. 34. And if we round this to 2 decimal places, that'd be that 5 would make the 9 go up to 10 and make the 4 go up. So it's going to be 34.5. Is what that 34.50. Okay. That's the short leg. So we know the sides are 34.50 for the shortest leg. The longer leg was 20 more than that, so we just add 20 to that. It'll be 54.50. And then the longest side was 30 more than that. That'd be 64.50. Those are all yards. Let me put my measurement there. So long problem, but probably the most difficult of the geometry problems because you got to go through Pythagorean Theorem. Just has a lot of operations to it that you've got to deal with. Okay. All right. The next type of problem is not a geometry. It's dealing with numbers. Okay. And when we're dealing with numbers, one of the things that they'll throw in here is what's called consecutive integers. Okay. So they'll give us a problem. Let's say find 2 consecutive integers whose product is 110, maybe something like that. And there's different ways to work this. I'm going to show you how to do it with a quadratic equation. A lot of these problems you can find the answer just kind of logically by taking a guess and working from there. But I'm going to show you how to do it with a quadratic equation that works really nice. All right, when we're dealing with consecutive integers would be numbers that are in order, like -3 and -2 are consecutive integers. Product is multiplying. So if the numbers were -3 and -2, the product is 6. Okay. Another way of thinking about consecutive integers would be like the numbers 8 and 9. 8 and 9 are consecutive because they're in order. And 8 times 9 would be 72. So that's what we mean by consecutive integers. All right. Now, the way that we set up the problem for this is we let the first integer is x. So the first one's going to be x. The second one is always x plus 1. So if the first one was 8, to get 9, you go 8 plus 1 is 9, right? If the first one's -3, to get the second one, you say -3 plus 1, get -2. That's consecutive integers. That's how they work, okay? So the first one's going to be x. The second one's going to be x plus 1. We don't know what 2 integers have a product of 110. So we set up this problem. First integer times second integer equals 110. This is almost exactly like the area problem for the poster. length times width equals area, that sort of thing. So here we're going to multiply out x times x and x times 1, be x squared plus x equals 110. All right, and then what do we need to get this equal to? 0. Good. 110, not 100. So we subtract 110 from both sides. X squared plus x minus 110 equals 0. Okay. Then we got options. We can factor it or we can solve it by quadratic formula. Again, quadratic formula works every time. So that's probably the way that I want to work all these, that I get a choice on. Okay. So A is 1, B is 1, C is negative 110. Negative B, so the opposite of positive 1 is negative 1, plus or minus. And then we have 1 squared minus 4 times A times C, divided by 2 times A. Okay? And we're working that out. So I'm going to take calculator and help me do 1 squared minus 4 times A times C. 441 underneath the square root. So negative 1 plus or minus the square root of 441 over 2 times 1 is 2. I'm pretty sure the square root of 441 is a nice number because they told me that the problem was integers. Integers are not decimals. Okay, so I'm going to work out the square root of 441. It's 21. So I have negative 1 plus or minus 21 over 2. This problem is not a measurement problem. So I've got to do both answers here. So I have x equals negative 1 plus 21 over 2 and x equals negative 1 minus 21 over 2. I've got to have the positive and the negative on this one because we're not dealing with measuring a shape. We're dealing with just integers. So they can be positive or negative. Okay? So this answer be 20 divided by 2, which is 10. So x, the first integer, could be 10. This one is going to be negative 22 over 2, which is negative 11. So the answers, all right, could be 10 and 11 or negative 11 and negative 10. Could be either of those. Okay. 10 times 11, hey, that's 110. Negative 10 times negative 11, that's also 110. Okay. And again, I'm getting that by just saying 10 plus 1, negative 11 plus 1. That's how I'm getting the other number. Okay, remember, your first integer is always x. Your second integer is add 1 to that. Get the other one. Okay. And again, some of these consecutive integer problems you can solve by just working it out, logically thinking, hey, I know what numbers multiply to be this. Let's get two of them that are real close together. So you can solve them that way, but that's just showing you how to do it with a quadratic equation. All right. All right. Let's do a little bit more solving, and then we'll do some stuff with graphs of functions to finish up. So we're going to do some inequalities. It'll be the last bit of solving of quadratics that we'll talk about, and how that kind of takes what we know already and then expands on it just a little bit. Okay, so section 1.7, quadratic inequalities. Quadratic inequalities. They are just quadratics that have a less than or greater than, less than or equal to, or greater than or equal to symbol. It's just the same A lot of the same stuff, but we're dealing with inequalities, so that changes how our answers work out of that. So quadratic inequalities, we're going to do a lot of the same stuff. So it's going to be give it a little bit more practice with quadratic formula and trying to solve an equation, and then we're going to do the inequality part is taking it and doing a little different take on how the answers work. Because remember, inequalities don't just have a single number as an answer. It's going to be a range of numbers. It's going to be some sort of interval of numbers out of that. So let's start with this one. Real easy one to start with. X squared minus x minus 12 is less than or equal to 0, or less than 0. No equal to mark this time. Okay. With these quadratic inequalities, the rules are the same as far as solving it with factoring or quadratic formula. You want to get 0 on one side. Okay. Always. That makes it easy to test and easy to work with. Okay. So this one already has 0 on one side. So we're ready to do some work. So what we're going to do is the first thing we're going to do is we're going to get 0 on one side. This one already has that. So check, we're done with that. The second thing we're going to do is solve the equation. All right. So we're going to take this inequality and we're going to treat it like an equation. That it's equal to 0. Okay. Multiple ways to do that. Factoring is one way. Quadratic formula is another way. I'm going to use quadratic formula because it always works. Okay. And we're going to get the answers to this equation. Those are not the answers to the inequality. That's important for you to remember. Okay, because it has an inequality in the original problem, we're going to solve this equation, and it's going to help us find the actual answers to the inequality. So A is 1, B is -1, C is -12. So we're plugging those in the quadratic formula. So that's going to be 1 plus or minus the square root of -1 squared minus 4 times A times C. All that divided by 2 times A. So we're just working this part out. So -1 squared minus 4 times 1 times -12. So we get a 49 underneath the square root. So 1 plus or minus 40, square root of 49 over 2. We know that the square root of 49 is 7. So 1 plus 7 over 2 is 4. 1 minus 7 over 2 is -3. 2 answers. What we then do, the third thing that you want to do is set up a number line. -3 and 4. You don't have to have any of the other numbers. You just need those in order. -3 and then 4. You need to put those up there. Okay? They need to be in order. Smallest on the left, biggest on the right. Here's what's happening. We know because it is a regular less than symbol that those numbers are not included. Okay? So we need to check answers to the left and to the right of each of those. Okay? So we need to pick a test point. 3 different tests. I'll do 3 different colors here. We need a number that's to the left of -3. What's a number that's less than -3? -4 works. You could do -10. You could do whatever number you want to. Doesn't necessarily have to be -4. I think that's the easiest one because it's the closest and small. Okay. Then we need to test a number that's between -3 and 4. What is an easy number to plug in that's between -3 and 4? 0 is really easy. What else is easy? 1 would be also just as easy, right? So I'm going to use 0 because it's the easiest of all of them. But understand, you could use anything that's between -3 and 4. Pick things that are easy on you. 0 and 1 are always easy ones. So I'm going to pick 0. That's purple. And then we need a number that's bigger than 4. 5 is a good one. Again, you can use any number that's bigger than 4. If you want to use the number 113, you can. But I don't know why you would. Okay, just make things easy on yourself. What we're going to do is we're going to take those numbers and we're going to plug them into this problem up here where we've got it less than 0 into the inequality. Okay, so set up a number line, pick test points or test numbers. Okay. When I plug in -4, and I'm going to use the calculator to do this. -4, I'm going to put parentheses, -4 squared minus parentheses, -4 minus 12. And I'm going to hit enter. I get +8. Is +8 less than 0? Is that true or false? It's false. So that entire section there is not an answer, okay, because that's false. Then I'm going to plug in plug in 0 for x. I think I could do this without the calculator, but I'm going to show you it's the same process no matter what number you pick. So instead of putting in -4, I'm putting in 0 this time. I get -12. Is -12 less than 0? Yeah. So this part's true. So we know we've got answers that are between -3 and 4. Any number that's between -3 and 4 is an answer. We could have answers over here with this area too. So I'm going to check that. So I'm going to plug in 5. So parentheses 5 squared minus parentheses 5 minus 12. Get +8. Is 8 less than 0? No, that's false as well. So the answers are in this area here. Okay? The answers, the way you write that, is with interval notation. We are not including -3 and 4 because the inequality did not have an equal to mark. So we need parentheses from -3 to 4, close parentheses. If it had an equal to mark, we would put square brackets out of that. We'll do one that's got an equal to mark next. Okay. So a little longer process for the inequalities. You got to do this testing thing that's going on. But overall, not any different than solving an inequality. We won't have any word problems with inequalities either. So don't worry about that. All right, because that could be extremely long. All right, so let's look at this one. 2x squared plus 5x is greater than or equal to 12. Okay. So first thing we want to do is get it in descending order and 0 on one side. This one is easy to get 0 on one side by just subtracting 12. So 2x squared plus 5x minus 12 is greater than or equal to 0. Got it that way. The next thing we want to do is we want to solve this like it were an equation. So 2x squared plus 5x minus 12 is equal to 0. And I'm going to do quadratic formula. A is 2, B is 5, C is negative 12. So negative 5 plus or minus the square root 5 squared times 4 times 2 times negative 12. Divided by 2 times A. I'm going to use the calculator to help me get that discriminant. Find out what that is under the square root. So parentheses 5 squared minus 4 parentheses A parentheses C. 121. It's got a nice discriminant. 121, I'm pretty sure, has a nice square root. I think it's 11. I'll use my calculator to help me. 121, 21. There we go. And it is 11. So that works out nice. So I have negative 5 plus 11 over 4. Negative 5 minus 11 over 4. So negative 5 plus 11. Six divided by 4. I'm going to reduce that fraction. 2 goes into both of those. 3 over 2. Okay. And then negative 5 minus 11 over 4. Happens to be negative 4. Works out nice, that one. If you did the other one with the calculator, if you did negative 5 plus 11, and then you divide it by 4, it's going to give me a decimal, and I can hit math, enter, to get it back to a fraction. All right, so now, once I have these two numbers, I know that I'm going to set up a number line with those two numbers on it. So we're going to have 3 things that we got to plug in, because we're always going to get 2 answers with our inequalities or quadratics. So which one goes on the left here? The smallest one's negative 4. Negative $4 is less than $1.50. So that's the order they need to be in on our number line. That'll help us get some test numbers. So our test numbers, something to the left of negative 4, that'd be like negative 5. I could check 0 in the middle there again, since it's between negative 4 and 3 over 2. And then something bigger than 1.5. Positive 2 is bigger than 1.5. Okay. Again, you can use whatever number you want to, as long as it's in the in the right range there. Okay. So I'm gonna check that in this inequality right here that I've got. So that's what I'm checking against. So I'm going to work out 2 parentheses negative 5 squared plus 5 parentheses negative 5 minus 12. Okay. 2 parentheses negative 5 squared plus 5 parentheses negative 5 minus 12. I get 13. Is 13 greater than or equal to 0? Yes. 13 is greater than or equal to 0. So that means I've got answers from negative infinity all the way up and including negative 4. Now I'm going to check the 0 in the middle. So on my calculator, I'm going to 2 parentheses 0 squared plus 5 parentheses 0 minus 12. I should get negative 12. I do. Negative 12 greater than 0? No, that part's false. So none of the answers between negative 4 and 1.5 work. Okay, so I'm not going to count those. It's possible that the numbers to the right of 3 over 2 work. And it's also possible that they don't work. So we got to test that too. On my calculator, I'm going 2 parentheses 2 squared plus 5 parentheses 2 minus 12. Get that answer. Hey, it's 6. Is 6 greater than 0, greater than or equal to 0? Yes. Okay. So it's important to know that those are included. So they're square brackets. Okay. So the solution set for this. Negative infinity up to -4 with a square bracket. U for union, because we're skipping all these numbers in between. So that's the U. That's what's skipping those. Square bracket 3 over 2 to positive infinity. That's how you would write the solutions to that particular problem. Okay. So solving the inequalities, solve it like an equation, and then build this number line thing here and test. And that's going to tell you how to do that. So it's just one extra step is what I call it. It's really like 3 extra things, but it sounds better when you say 1. So that's way I think about that. All right. So again, with the inequalities, the way you know to use the square brackets, if it has the equal to mark, use the square bracket. If it doesn't, it's parentheses always. Okay. So quadratic inequalities with that. So nothing, it doesn't get any harder than those, honestly. And it's the same from there. All right. One more section and we'll be out of here for today. All right. So today, the last section that we'll talk about is less about solving and more about the graphs of quadratic functions. Okay. Quadratic functions, and this is skipping all the way to chapter 3. So we've been in chapter 1 for the first 3 sections. We're going to go to chapter 3 for this section. And chapter 3 talks about quadratic functions. And quadratic functions are quadratic equations that instead of equal to a number, they're equal to y. So we're talking about quadratic functions. My brain's still on vacation. So when we're dealing with quadratic functions, what we're going to be talking about are functions, f of x. Remember, that's the same thing as y. So it's y values. And then the form that they have is like that standard form that we dealt with quadratic formula. So it's just very similar stuff. And what we're going to be talking about is the graphs of these things. So I'm just going to sketch a general graph for a quadratic function. And a quadratic function, looks something like that sometimes. Sometimes it will flip upside down and kind of make a frowning face. It looks, like that. Okay. Those graphs each have important pieces. Okay. The first important piece is what's called an axis of symmetry. The axis of symmetry is this imaginary line that could be drawn down through the center of the parabolas. Okay. And I put it as a dotted line because it's a visualization. You're just imagining that it's there. But since it says axis of symmetry, when things are symmetric, that means if you fold them perfectly, in half, they match up. That's what the axis of symmetry is. It's that folding line that if you folded the parabola at that spot, they would match up on each side. So to find that equation of the axis of symmetry, there's a short, easy formula for it. The formula is x equals negative b divided by 2a. Yes, that is similar to the quadratic formula. It's because it's a quadratic. That's why they're similar, because it's very much related. So negative b divided by 2a is going to be the equation for the axis of symmetry. Always going to be x equals negative b divided by 2a. And what we would do is we're going to plug in the numbers and simplify that fraction. That's all we're going to do to find the axis of symmetry. Related to the axis of symmetry is the vertex. Vertex is this ordered pair. Let's see, really. Right there at the lowest point or the highest point on the parabola. Okay, highest point or lowest point. Both of those are called a vertex. Okay, and the vertex is either a maximum or minimum. Maximum or minimum. Maximum if it's on the top, if it's at the top, at the peak. A minimum if it's at the valley. Okay, all right. And the way you're going to know that is by the sign of A. It's a maximum if A is negative or less than 0. If A is less than 0, negative, then it's going to be a maximum. If A is greater than 0, positive, it's going to be a minimum. Okay. A decides if the vertex is a maximum or minimum. Nothing else decides that. A is the only thing that can decide that. If A is negative, it's a maximum. If A is positive, it's a minimum. Okay. The vertex is an ordered pair because we're talking about a single point, right? So the ordered pair, negative b over 2a, is the x value of that ordered pair. That's the same thing as the axis of symmetry. So once you find the axis of symmetry, you get half of the vertex for free. That's a good thing. Okay. 2 birds with 1 stone, as we used to say. All right. And then to find the y value, if you've got the x value, to find the y value, you just plug it in and work it out. And so the notation for that is f of negative b over 2a. Okay, so that's just plugging negative b over 2a. Whatever that number is, plug it in for x and work it out. Get the y value. That tells you the location of the vertex. Okay. Axis of symmetry, x value of the vertex, always match. If they don't, something is terribly wrong. Okay. All right. Now, another important point or place on a quadratic function is the y-intercept. Y-intercepts are where they cross the y-axis. Right there's a y-intercept. On this other one up here, right here, is a y-intercept. Y-intercepts, if it's in standard form, are going to be at 0, f of 0. We'll go, so 0 for x. Plug it in. Work it out. That's going to get you the y-intercept. Always. Y-intercepts. Plug a 0 in for x. Work it out. That's all we got to do. In most cases, if it's in standard form, that will be the c that's on the end. It's most of the time what it is. Unless there's some other numbers involved or it's in a different form out of that. But we can always plug a 0 in for x and get the y-intercept. Any problem we ever encounter, that's what we can do to get the y-intercept. Plug a 0 in for x. The last thing is the X intercepts. And we won't find these on every problem, but we've been doing that all day. The X intercepts are where ax squared plus bx plus c is equal to 0. Hey, guess what? That's the exact thing we've been doing all morning. It's finding the X intercepts. Remember we looked at the graphs on the first section. We looked at where it crossed the x-axis. Those are called X intercepts. They're going to be where the graph crosses the x-axis. Okay? X intercepts are where the graph crosses the x-axis. We just solve it, just like we've been doing all morning. Okay? So we're going to get a function. We're going to do all these things. We're going to find this stuff for it. We're going to look at the graph on the calculator for this. I'm not going to ask you to graph a whole lot of these by hand. I think the lab, you've got to graph some of them by hand. But if you can find the vertex and Y-intercept and the X intercepts, the graph's easy to sketch. Just get close. You know, you ain't got to be perfect with it. But the vertex is all those things are very important parts to the graphs of quadratic functions. So into all right, so let's deal with some of them that are in standard form, and then we'll deal with ones that are in what's called vertex form. So let's do standard form first, and then I'm going to show you vertex form, which is a little different form, but it gets you some other stuff for free that's out of that. So let's look at our first example. Find the axis of symmetry, vertex, and intercepts for the function. Notice I just said intercepts. That implies X and Y intercepts out of that. Okay. Then look at the graph. Okay. All right. So first example, let's f of x is equal to x squared plus 6x plus 8. So very simple one to start off with. No big numbers in there. Working out of that. So we're going to find the axis of symmetry, the vertex, and the intercepts for this function. We're just going to go in that order. So I'm going to find the axis of symmetry first. Remember, it has a nice formula. Negative b divided by 2a. X equals negative b divided by 2a. So plugging in the stuff we know. I know b is 6, so negative b would be negative 6. A is 1, so I know 2 times a would be 2 times 1. So that'd be negative 6 over 2, which is negative 3. So the axis of symmetry is this equation, x equals negative 3. It is not just the number negative 3. Okay? Axis of symmetry is always an equation of a line, x equals negative 3. Always that equation. Okay? So be careful of that. All right? Now, because I found the axis of symmetry, I get the vertex. I get half of it for free. I know that the x value of the vertex is negative 3. So maybe I'm going to put that in blue there. Negative 3. I've just got to find the y value of the vertex. If I've got an x value, to find the y value, I take it and I plug that x value in. I find out what's f of negative 3. That means plug 3 in everywhere there's an x. So, or plug negative 3 in everywhere there's an x. I can do this with my calculator. I can do this by hand if I wanted to, but I can do this with my calculator, showing that I'm plugging it in. And then I'm just going and saying negative 3 squared plus 6, parentheses, negative 3, and then plus 8 on the outside there. Hit enter, and I get a negative 1 as my y value for my vertex. So this is working out to be negative 1. So there is my vertex. Okay. I'm also going to decide if this is a maximum or minimum here at this step. So the vertex is either going to be a maximum or minimum. It's going to be decided by what is in front of x squared. What's in front of x squared here? What's a? Positive 1 or negative 1? And because it's a positive 1, then that makes this a minimum. If a is negative, it's going to be a maximum. If A is positive, it's going to be a minimum. Okay? What that tells me is that when I graph this thing, I should be seeing some sort of shape that looks like that. That's what the vertex being a minimum means. Okay, so when I graph this with the calculator, I should see a graph that looks similar to this. Okay, that it's opening up and it has a lowest point. That lowest point should be at -3, -1. We'll check that when we graph this in just a minute. Okay. The next thing that I want to find are my intercepts. Let's find the y-intercept first. It's the easiest one to find. The y-intercept, we plug a 0 in for x. So it's 0 squared plus 6 times 0 plus 8. What's 8? So my y-intercept is at 0, 8. So I plug a 0 in for x, gets you the y-intercept. No matter what form the problem is in, plug a 0 in for x, you get the y-intercept. Okay. All right. Last intercept to find is the X intercepts. These are the tougher ones to find because there's a little bit more work involved because you usually got to do quadratic formula or solving by square roots or some sort of form like that. So what we're going to do to find the X intercepts is we're going to set the problem equal to 0. X squared plus 6x plus 8 equals 0. And then we're going to solve that. I'm going to solve it by quadratic formula because that gets me an answer every time. Okay. So A is 1, B is 6, C is 8. So that'd be -6 plus or minus 6 squared minus 4 times A times C over 2 times A. -6 plus or minus, and then just working out the discriminant, parentheses, parentheses 6 squared minus 4, parentheses 1, parentheses 8. My discriminant is 4, which I know the square root of 4 is 2. So I'm going to be able to work out the answers to this because it worked out to be a nice number when I took the square root. So I'm going to hit -6 plus 2 and -6 minus 2. -6 plus 2 is -4. Divided by 2 is -2. -8 divided by 2 is -4. So I get x equals -2 and x equals -4 as ordered pairs. That's -2, 0 and -4, 0. We should see the graph crossing the x-axis at -2 and -4. We should see the lowest point on the graph at -3, -1 because it's a minimum. We should see the graph crossing the y-axis at +8. So what I'm going to do is with the graphing calculator, I'm going to hit y equals. I'm going to clear that out. I'm going to type in that problem. X squared plus 6x plus 8. Hit graph. I'm gonna hit trace -3 to check my vertex. Remember, my vertex should be -3, -1. Look at the cursor. It's at the lowest point. My value in the ordered pair thing there is -1. That's good. Check. I'm going to trace my x-intercepts. My x-intercepts were -2. Hey, that's right there on it. And -4. Right there on it. What was my y-intercept? 0, 8, right? So I'm going to trace 0. Right there, it's crossing at 8 on the y-axis. So I've checked all of those things by looking at this graph. Okay? That's what we're finding are the pieces that make this graph up. Okay? That's what we're trying to find. Yes. We're finding the pieces that make that picture happen. Axis of symmetry, that's that imaginary line that goes up through here like that. That's where that's at. It's not going to draw it on the picture with your graphic calculator, but it goes right through the vertex. You know it's there. Okay? That's what we're looking for here. It's what we're trying to find out of this with these functions. That's our main goal. All right. Let's look at another one. Example B. Call this one g of x. Just change the name of the function. And let's say we had negative x squared plus 4x plus 2. Negative x squared plus 4x plus 2. Again, we're going to do the same things. We're going to find the axis of symmetry. And I'm going to abbreviate that. Axis of sim. And so we're going to use that formula. X equals negative b over 2a to get that. Always going to be that formula for axis of symmetry, quadratic functions in standard form. All right. Now, negative b in this case, maybe it's helpful to make that list up here because we're going to use it over and over. So that a is -1, b is 4, c is 2. So we know those things, and we're plugging them in. Negative b would be -4 over 2 times -1. So that'd be -4 over -2, which is +2. X equals +2 is our axis of symmetry. Okay. Next thing we're going to find is the vertex. We already have half of it. 2 is the x value. So we just need to find out what 2 is when you plug it in. I'm going to get a little help with the calculator here. So negative parentheses 2 squared plus 4 parentheses 2 plus 2. Oops. 6. So 2, 6. Is that going to be a maximum or a minimum? What? No, we want to look at A. A is negative here. A is what decides. So if A is negative, it's going to be a maximum. What that tells us is the graph is going to look something like that. And if you're ever in doubt, just go ahead and graph the problem. Go to y equals, type it in, negative x squared plus 4x plus 2. And hit graph. And you see, hey, it's opening down like that. We've got a peak here at the top. So we know that that's a maximum out of that. So that can be helpful for that. Relate these things we're finding to the graph that exists. And that's the key to this. Is what we're trying to do here. Next thing would be our intercepts. There. Intercepts, the Y-intercept. Plug in a 0 for X. It'll be 0, 2. If I look back at the graph that I made, is it crossing the x-axis at 2? Yeah, it is. I can see it right there. X intercepts. Again, this is the most difficult part of this, is finding the x intercepts. And that's just taking that problem and setting it equal to 0. And I'm going to do quadratic formula for this one. -4 plus or minus 4 squared minus 4 times -1 times 2 over 2 times -1. Four squared minus 4 times -1 times 2. It's 24 underneath the square root. Does 24 have a nice square root? If it were 25, it'd be 5. If it were, 16, it'd be 4. 24 is not either of those. It's in between those. So that means that I need to simplify the square root of 24 using the factor tree stuff. I know 8 times 3 is 24. 4 times 2, 2 and 2. So I got a pair of 2's, and then a 2 and a 3 left over. So that's going to be -4 plus or minus 2 square root of 6 over -2. I'm going to split that apart with that denominator of a -2 and simplify. So that's going to be -4 divided by -2 is 2. These 2's cancel each other out. 2 plus or minus the square root of 6. If we do 2 plus the square root of 6, we can get a decimal approximation for that. If we do 2 minus the square root of 6, we can get a decimal approximation for that. I'm going to use the graph to help me do that, because I already got that equation graph. If I hit trace 2 plus the square root of 6, it'll give me a decimal 4.45. That's where it's crossing the x-axis. That's the positive, the plus one, 4.45. And then the negative one, the minus. So 2 minus the square root of 6, -0.45. Where it's crossing the x-axis. So our x-intercepts, the ordered pairs, would be 4.45, 0, and -0.45, 0. That'd be the decimal approximations for them, which is, we're looking for, where's it crossing the x-axis. And, again, the graph is what we're after here. That graph is the main event. What we're finding with these little formulas and everything is just confirming what's happening in this picture. Okay, that's all we're doing, is confirming that this picture matches up with the problem. Okay, so if you can get the picture, a lot of times you can just kind of borrow stuff from the picture to make sure you're right. The formulas and everything work no matter what the numbers are. The graph should match up to that. If it doesn't, something's going wrong. Okay, so standard form, that's how you're going to do it. So you're either going to get it in standard form or the next thing is called vertex form. That's the last thing of the day. Okay, and vertex form is nice in some ways and not so nice in other ways. It's kind of like standard form. Standard form had a couple of nice things about it that we got real easily. Vertex form has a couple of nice things we get real easily, but then the other stuff is not as easy, but it's still, it's definitely directly related to what we've done in the past. Vertex form. If it's in vertex form, what do you think they give you really easy out of those four things we're finding? They give you the vertex real easy out of that. So this is what it's called, vertex form, because you can look at it and tell what the vertex is automatically. Okay, so vertex form looks like this. This function f of x is equal to a parentheses x minus h squared plus k. The vertex is right there in it. It's the ordered pair h, k. You pull those numbers direct from the problem, and you get the vertex for free. Because we get the vertex for free, we get the axis of symmetry for free, just in a different order this time. We get the entire vertex for free. We get the axis of symmetry. It's going to be x equals h every time, whatever h is. Whatever the x value of the vertex, that's the axis of symmetry, just like it was in the standard form. Nothing's changed about this. This is still going to be a parabola, that same shape. It looks the same. The equation just is different. Okay. Now, what the vertex, whether it's a maximum or minimum, is still going to be decided by a. If a is less than 0, we're dealing with a maximum. Maximum. If a is greater than 0, a is positive, we're dealing with a minimum. That has not changed. It will never change. A decides, is it a max or min? Okay. A decides, is it a max or min? Okay. Now, Y-intercept. Again, you're going to plug in a 0 for the x. And work that out. 0, whatever f of 0 is. The X intercepts, again, you're going to take the problem and you're going to set it equal to 0. And the kicker to this one is you're going to solve by square roots. So we're going to get a little practice solving by square roots. With the standard form, you're going to solve by quadratic formula. That's the best way to do it. Okay. With vertex form, we're going to solve by square roots because that's the best way to do that one. Okay. And we're going to work a few examples of this. Okay. A couple of them actually. All right. Now, what letter are we on here? C. First example in standard, or not in standard form, but in vertex form. Let's take 5 parentheses x minus 6 squared minus 20. Okay. So this is vertex form, okay? Because we see the parentheses with the squared on the outside, we got a number in the front, and we got a number added or subtracted on the outside. So we recognize that this is vertex form. That's the form that is in, with numbers plugged in its place. Okay, so this makes finding the vertex and the axis of symmetry super quick and easy. So that's what we're going to do. Axis of symmetry. Again, I'm just going to abbreviate that. It's going to be x equals h. What's h for this problem? 6. That's it. It's that easy. The vertex. H is 6. What's k for this problem? negative 20. Keep that sign with it. So if it's a minus out here, it's going to be a minus in the vertex. The H, it's always the opposite. See, that's a minus 6. It's positive 6 when you bring it out. So the parentheses, it's always going to go the opposite out of that. Okay. So we get the vertex, we get the axis of symmetry really fast and easy when vertex form. The vertex for this one would be a maximum or a minimum. Which one? And why? Well, it's all dependent on A. A is positive 5. So if A is positive, that's going to tell us it's a minimum. So we know the shape looks something like that. If I'm ever in doubt, I'm going to go to my calculator. I'm just going to go to y equals, and I'm going to type in that problem. 5 parentheses x minus 6, close parentheses, squared, minus 20. And I see I can zoom out a little bit if I need to. And I see that shape where it's opening up, and I got our lowest point out of that. Okay, see that that's what's happening. All right, now the last parts, the intercepts, are not the easy ones to find with this. Okay, so we're going to find those, but the process is still the same as far as what the theory that you're going to with this. So the intercepts, to find the y-intercept, we're going to plug in a 0 for x. We're going to plug in 0. So that's 5 parentheses, 0 minus 6 squared minus 20. So it'd be 5 times negative 6 squared minus 20. And if I did that by hand, it'd be 5 times 36 minus 20. 150, 180 minus 20 is 160. So big number for the y-intercept, 0, 160. If I did it with the calculator, it's the same idea. Okay, take it, quit. So I'd have 5 parentheses, 0 minus 6 squared minus 20. I'll check my math here. Yeah, I did it right. 160. So I'm just working that out, plugging a 0 in for x. That will always find you a y-intercept. Plug a 0 in for x. Okay, but plugging in a 0 in for x gets you the y-intercept at 0, 160. If I look at my graph for that problem, you know, we're zoomed out here. We see this thing is still going up, and it's pretty good ways up there before it hits the y-axis. So that makes a lot of sense that that's what's happening. It relates to the graph that we're drawing. Now let's find the x-intercepts. This is the tougher part of this vertex form problem, is finding the x-intercepts. So we're going to take that problem, x minus 6 quantity squared minus 20, and set it equal to 0 and solve it. So we're going to solve it by square roots. So the first thing I'm going to do is move this 20. So I can get this squared part. Remember this squared part by itself. We talked about that earlier. The first section we were talking about was solving. Get the squared part by itself. So that's why I'm moving the 20. And then I'm going to divide by 5 to get the squared part by itself. X minus 6 squared is equal to 4. 20 divided by 5 is 4. The next thing I'm going to do is take the square root of both sides. Plus or minus on the side with the number. This one works out nice because the square root of 4 is 2, so that's plus or minus 2. Last step is add 6. So x equals 6 plus or minus 2. 6 plus 2 is 8. 6 minus 2 is 4. So my x-intercepts are 8, 0, and 4, 0. 8, 0, and 4, 0. If I look at my graph, I should see it crossing the x-axis at 8 and 4. Okay. If I hit trace 8, there it is. Y value 0. It's crossing the x-axis there. Trace 4. Boom. If I hit my vertex should be at 6. Trace 6 with a y value negative 20. Hey, there it is. My x-intercept should be, my y-intercept should be at 0. So if I hit trace 0, hey, it gave me the y value there. That's nice. So my graph matches the stuff I found. That's what we're doing in this section. It's matching up the stuff we can find using math and algebra with a graph that's drawn. That's what we're trying to find. Let's do one more in vertex form, and then we'll get out of here for the day. G of x is equal to negative 2 parentheses x plus 5 squared plus 8. Okay, so changing up some signs and what's going on here. So we're going to get the axis of symmetry and the vertex. We'll get those for free because this is in vertex form. I can tell because it has the parentheses with the squared number in front and add or subtract a number on the outside. If there's no number in front, then you assume it's a 1. If there's no number on the outside, you assume it's a 0. Okay, so make sure if there's no number added, subtracted, it could still be vertex form, but the k value would be a 0 if there's nothing. If it were written like that, k would be 0. We got a plus 8 there. So. All right, so axis of symmetry. X equals, and then this is supposed to be x minus h squared. But it's a plus sign in there. So we're going to take the opposite of that. So the axis of symmetry should be x equals negative 5. Always take the opposite of the inside of the parentheses. Always. Vertex will be negative 5, positive 8. Okay. Always stay the same on the outside. What you see on the outside is the way it is. Inside could be opposite. Maybe inside out. Maybe a way to think about it. Okay. Is that a maximum or a minimum point? Is the vertex. Very good. That negative 2 in the front makes it a maximum. Very good. All right. Next thing is the intercepts. Let's get the y-intercept. Plug a 0 in for x. It's always what you do, no matter how big or small the problem is, to find the y-intercept. Plug a 0 in for x. So I'm just going to use my calculator to help me out here. So I'm going to hit negative 2 parentheses 0 plus 5 squared plus 8. Negative 42. So my y-intercept is at 0, negative 42. X-intercepts, take the entire problem, negative 2, x plus 5 squared plus 8, and set it equal to 0. I'm going to solve it by square roots. I'm going to subtract 8. Divide by negative 2. Get the squared part by itself. That's the key. Get the squared part by itself. Works out nice because I can take the square root of 4. X plus 5 is equal to plus or minus 2. So it's similar to the previous problem. subtract 5, get -5 plus or minus 2. So I get x equals -5 plus 2. And x equals -5 minus 2. I get it crossing the x-axis at -3 and -7. So my ordered pairs for my x-intercepts are at -3, 0, -7, 0. Let's verify that with our graph. Equals, type in that equation. So clear that one out. -2 parentheses x plus 5 squared, and then plus 8. Hit graph. I'm gonna show you how to get your graphing calculator back to the normal window. You hit zoom 6. That'll set it back to the 10 by 10 window that it's normally at. Okay, zoom 6 always sets it back to 10 by 10. If you need to zoom out so you can see more of the picture, you just hit zoom and then arrow down there to zoom out. And wherever you put the cursor, that's where it's going to zoom out from. Like that's the focus point. I always just usually zoom out from the center of it, so it still keeps the same kind of look. So we're looking for where this thing crosses the x-axis. If I hit trace -3, hey, right on it. And then trace -7, right on it. Good job. And then the vertex, the y value or the x value should be -5, I think. So trace -5. Yeah, there it is. And the y value is 8. We got that from the standard or from the vertex form of that. It's opening down because of the -2 that was in the front. We see the maximum point up there at the top. If I hit trace 0, that'll get me my Y-intercept, which is -42. Works out real nice. So what we're doing is just verifying the things that are happening on this graph are happening with the equation. We're just working our way back and forth with those. So always nice to have that in there. I'll put that picture in my notes. Looks good. All right. Now, problems that would be good out of the textbook just to look at before you start zooming into the quizzes and labs in that section 1.4, 1.5, page 118, 1 through 49, odd, and then was it 1.7 was the inequalities, page 146, 39 through 51, a smaller set there. And then the last section we did was 3.1, page 293, 1 through 81. It's a good set. Now, just some of those out of that would be good to look at out of the textbook for you to get ready for your stuff out of that. So reminders about things going on. If you did not finish the quizzes